Alrighty, we are going to start our lesson on 12.4, which is operations with functions. So let's get started. We are going to do the recall today. It says evaluate each function. So this first one, A, says f of x equals 3x squared plus 2x minus 1. Just a reminder that a function, you just throw an input in, do the math that it asks you to do, and then you get an output. So this input for us is going to be x equals 1, and the notation for that, when you're changing the input from x to 1, is f of 1, and everywhere there's an x, that is going to become a 1, and that's our input. And then we would plug it into our calculator, or if we don't have a calculator, we're just going to follow order of operations. So we got to do the 1 squared, which is 1. And then that's 3 plus 2 minus 1, which equals 4. Okay, so a lot of this you've already seen before, but I really want you to focus on that a function has an input. That's what you plug in. And then you do math to that function, whatever the function math says, and then you get an output. So we are going to expand our knowledge of functions right now. So let's make sure we're getting the basics down. So this one's going to be g of 16, which means log base 2 of 16. So you have to say 2 to what power is 16, and that's going to be 4. And then this one right here, this function's job has a cube root in it and a plus 1. So we're asked to find h of 7. So just make sure you simplify under the radical first, because the radical symbol is a grouping symbol, just like parentheses and fraction bars and all the other stuff, brackets, things like that. So we do the underneath the radical first, and that's going to be the cube root of 8. So you're saying, can I get 3 of a kind out of 8? And that would be 2, because 2 times 2 times 2 is 8. Okay, so that's the little bit of a refresher before we move into what we're actually going over today, which is all things functions. So operations with functions, adding, subtracting, multiplying, dividing, composing, and inversing are all the things that we're going to be doing in this lesson. So let's see. Some of them you're going to find really easy because it's just, oh, wow, it's that straightforward. And then other ones you're going to have to think about for a bit, but you'll also see that they're pretty straightforward too. So let's see right here. The first one that we're going to look at right here is addition. So I'm right here. And it says, if you're asked to add two functions together, f of x plus g of x, all you have to do is take the f function and add it to the g function. That's it. So they make some fancy notation by writing it this way, but really all it means is this right here. So in our example right there, it says add 4x minus 5 to 2x squared. So f of x plus g of x. So f plus g of x is the same thing as just taking f of x and adding it to g of x. So be really careful here. I don't want you to think that this right here has anything to do with distributive property. So it looks like you would multiply that x to both f and g, but that's not what we're doing here. That's not the notation that we have. You have to know function notation. So just be really careful with that. So that means we're going to be taking 4x minus 5, which has two terms. So I'm now putting parentheses around it, and 2x squared, which only has one term, so I don't have to. And then just simplifying. There's not much we can do here because simplifying is either combining like terms or canceling common factors, and there's nothing really that we can do with that. If we want, we can put it in standard form. So that would just be that the highest power of x goes first, and since the highest power of x is x squared, we put that first. Okay, moving on to the next one, which is subtraction. I always tell you guys, if anything's ever going to trick you, it's going to be subtraction. So always put parentheses around what you're subtracting. So again, just like with subtraction, we did that it just means f of x minus g of x. It doesn't mean that we're going to distribute it all. So just, let's see. So if we're doing f minus g and the input is x, that's the same thing as inputting x into f and inputting x into g and then completing the subtraction. So this would look like 4x minus 5 minus 2x squared. Now, if this g function had two terms in it, I would definitely put it in parentheses because that would mean that I would distribute that negative, but it doesn't. So parentheses aren't necessary, but if they make you feel better, then you can put them in there. So that's our answer for the subtraction. Moving on to multiplication. So again, just looking at these things here, with multiplication, this little thing right here, notice it's a dot right there because we're going to see something else in a little bit. Look at that dot. It's a dot. It's a closed dot. It means multiply. And so make sure you know the difference between that and what we're going to see down below, which looks like an open circle, kind of like a degree symbol on like 180 degrees, but we'll get to that in a minute. So back to this. We are doing f of x times g of x. So that just means multiply. Again, you're just going to do what you know how to do. So f times g of x equals f of x times g of x. You don't have to write that on every problem if you know what to do. So really what we have is 4x minus 5 times 2x squared. I'm going to put parentheses around it. It's just a good habit. You don't need to. But then how do we do problems like that? We FOIL them, or distribute them, not FOIL them. Okay, so that would be 4 times 2 is 8, and x times x squared is x cubed. And then we have a minus 5 times 2 is 10, and there's nothing to combine with the x squareds, and it's already descending order, so that's our answer for that one. And finally, we get to the division one, which we know from last chapter, there's excluded values, but it looks like for this lesson, we're just going to not worry about excluded values, but have them in the back of your mind just in case something like that does come up. So we have f of x divided by g of x. Dividing is the same thing as a fraction, so it's easier to write it like that. So then we're going to do that. So we have f of x over g of x. So that equals 4x minus 5 all over 2x squared. Can I combine like terms or cancel common factors? You can't do anything with this, right? Because this right here is connected to 5. So that 4x is connected to the 5 with a minus sign, making 4x and 5 terms. And then down below you have 2x squared, but that minus sign makes it so that you cannot reduce these pieces. So you can't cancel those. So our answer is exactly what we got. And then just a friendly reminder from last chapter, x cannot equal 0 because then we'd be dividing by 0. So what I suggest you do right now is go ahead and pause this video and then take a look at example 1 and see if you're picking up what I'm putting down. I know it's like your gut intuition to just like power through this, but getting this practice and seeing what you know and what you need to ask questions on can be really helpful, and in fact is a big part of learning. So just a suggestion, I'm going to continue with it right now. So I know that the shorthand way to write f of x plus g of x is what they have right here. So they were like, it's too much to have to write all those parentheses. So we're going to shorten it. It doesn't feel much shorter, so I don't know what the point of that is. So what we're going to do is take the f function, which is x plus 5, and has 2 terms. So I put parentheses around it. Usually you don't need parentheses when you're adding, but it's always just a good idea. So then I have x and 2x makes 3x, and 5 and negative 1 makes 4. There's no excluded values because there's no denominator. Oh my goodness, look at this next one. It says h of minus g of negative 1. So what that means is h of negative 1 minus g of negative 1. And if you look up here, that's exactly what we were just doing, but now we have to plug in negative 1 into the h function. So input is negative 1 into h, and we're going to get an output, and then we have to subtract g's output for that same input. So sounds complicated, but once you see it, you're going to be like, oh, not so bad. So let's look at h of negative 1. So plug that in to that h function right there. So that's going to be 2 times negative 1 squared plus 9 times negative 1 minus 5. Obviously, the functions can change. So if you're wondering where I'm getting this from, this is the h function. So I need to do all the math for that h function first. And I get negative 1 squared is positive 1 times 2 is 2 plus negative 9 minus 5. So that all gives me negative 12. And then I'm going to go into my next function that it tells me to go to. So I'm just following the rules, which is g of negative 1. And I'm just going to plug in g of negative 1. So that's going to be 2 times negative 1 minus 1. Yep, it's a different function. That's why they named it g and not h this time. So that's where I'm plugging into. And when I do all that math, I end up getting 2 times negative 1 is negative 2 minus 1 is negative 3. So when I set up my subtraction for h of negative 1 minus g of negative 1, that's going to be negative 12 minus negative 3. So I know I normally say if it only has two terms, put it in parentheses, but that rule also applies if your term is negative. Put it in parentheses so that you do see your double negative, and that ends up being negative 9. Last one that we're going to do right here is h of x divided by f of x. So I'm just going to color code the f function green so that I know where to grab my information from. So this is the same thing as h of x divided by g of x. So this is 2x squared plus 9x minus 5, and then f of x is x plus 5. And we're dividing, and it looks like we might be good, but you can cancel common factors, and x plus 5 is a factor. And normally, I hope your gut is to t-chart when you see three terms, but especially because that number is 5, which means that it might be a factor like x plus 5 as part of it. So we're going to go ahead and t-chart that. 2x squared, 9x minus 5, 2x and x. And then my guess is, if anything, this is going to be positive 5. So I'm going to put it down there. And I notice that gives me 10x. So then if this is negative 1x, when I crisscross add to the middle, it checks out. So this ends up being 2x minus 1 times x plus 5 all over x plus 5, just a review from last chapter. And then because these are common factors, they cancel, and we get 2x minus 1. And like I said, we don't have to worry about the excluded values, but if in the back of your mind you're going x can't equal negative 5, that's a good thing. Alrighty. Now we're going to move on to composition of functions, which is where you put one function as the input into another function and get a new output function. Sometimes we use numbers, sometimes we just use x. So pay attention to this, because if you're following along and looking at what I'm highlighting, it makes it way more easy, okay? So whenever you see this notation right here, it looks like it says fog. Really what it means is f of g of x. So what it means first is x will go into the g function, which it already will be, and then you'll plug that into the f function, and then you'll have your output, okay? So it goes through a couple of steps before you get to the output. what I do want to say here is order matters. So if it says f of g of x, like here, the f goes on the outside here. And if it says g of f of x, that we'll see it when we get down here, but g of f of 1. That's what it looks like. Okay, so let's pay attention to this. The other thing that I like to tell students when doing this is I keep saying that x is an input, right? And we use that pretty consistently in math. Another way to think of it is everywhere there's an x, just think of that being an input box. Hold on, I'm gonna go and erase that parentheses. So if you look at the f function, its job is to take each input, multiply it by 4, since the x is next to the 4, and then subtract 5. So it's kind of weird to think about it as a machine that changes things. It's just plug it in, then we're going to do some math to it. We're going to times it by 4, subtract 5, and that's our output. But that's kind of the way that you want to think of this function notation. We're going to put an input into it, and just like a machine changes things around, the function will do math to it to change it up, and then it'll spit out an output, okay? So what would that look like with the g function? So here, instead of having x squared, you can see that I'm using a box because sometimes that's easier for kids to process. I'll do it both ways in just a second, but I also want to color code this guy so we can see, okay? So now we're ready to do f of g of x. So it could be written like this, which looks like the word fog, and you would need to know that means composite function. So it would mean the same thing as f of g of x. So in everything we do, we start with the parentheses first. So that's what we're going to do here, is we're going to start here, which is g of x, which is this guy, the blue one, and we're going to plug it into the f function, okay? So let's take a look here. It looks like this. F of, well, what does g of x equal? G of x equals 2x squared. So instead of writing g of x, I've switched it over to the equivalent form of g of x, which is 2x squared. And now I'm going to take that and input it into the f function, which is 4 times 2x squared minus 5. So now, if you look at the yellow part that I'm about to highlight, this whole thing is f of g of x, because I took the g function and it became my input into the f function, and now it's going to spit out a third function. It's going to have an output, and it's just going to be 8x squared minus 5, because that's what we get from doing that. If you aren't sure about this way, if you look over here, I'm just going to, actually, I'm not going to do that. I'm going to plug in x's here, because this right here, f of g of x, says that we are going to plug in x to the g function. So I plugged x's into the g function, and my output is 2x squared. And then I'm going to take that and plug it into the f function's input box, which is anywhere there's an x. And you'll see we get the exact same thing. So I'm going to proceed without the boxes, because that might be confusing some people, or maybe it was helpful and you love the boxes. I'll also use Post-its in class, because that's easier to see that x is not x. It's just a placeholder for the word input. Input is too long to write, and mathematicians are lazy. So whenever you see these x's in the general form, it means input. You do something to plug into something else, okay? So let me explain what I mean with these down here. So again, it's always helpful if you're going to highlight your functions so you know where to go from there, okay? Don't make it more complicated than it needs to be. This says f of g of x. So f of g of x. Where do I start with? always inside the parentheses. So I'm going to take the g function and plug it into the f function. Let's look at the f function. So this is going to be 2, and then here's the input spot. What am I inputting there? The g function according to this, which is 5x. So I'm putting 5x there. Then what math do? I got to square it and subtract 4. Okay, so pay attention to that real quick, look it over. And so I just want to highlight a key couple of things here. First off, you are not multiplying this by x. So when you see this business, it doesn't mean multiply by x. You are physically going to take that x out and replace it with the new input, which in this case was 5x. So I took the x out, old input out, and new input in, and then we just simplify. So follow order of operations. 5x squared is 25x squared minus 4, and then that's 50x squared minus 4. Okay, next one. These ones are kind of cool. There's lots of different ways to do this. So we'll start g of f of 1. Okay, so now what we got to do is plug in 1 into the f function. So we have the 2 from the f function, and then the input for x is 1, and it's being squared, and then we subtract 4. So let's simplify the inside of that. 1 squared is 1, so that's 2 minus 4. So when we simplify all that, we get g of negative 2. And you know how to find g of negative 2. So now what we're going to do is move on by f function and move on to the g function. So g of negative 2 is going to be equal to 5 times negative 2, because the every input in the g function gets multiplied by 5, so that's negative 10. Whoa, look at this trippy thing right here. It says f of 2. It says plug in 2 for f, and then whatever you get from that, you're going to plug it right back into f again. So let's go ahead and again, f of negative 2. So we're going to take negative 2 and plug it into the f function. So I'm still working on those inner parentheses, so that's 2. And then negative 2 squared minus 4. So that equals, following some math, 2 times 4 minus 4. Make sure you follow order of operations, which is 8 minus 4, which is 4. So now my output from that little piece was 4, and then I'm just going to plug it back into f again. Okay, so it's just like kind of directions. Do this, then do that. So if I do that, f of 4, again, plugging back into that f function, and what happens to every input? It gets squared, then it gets multiplied by 2 and subtracted by 4. So squared is 16 minus 4, so that gives me 32 minus 4, which gives me 28. Okay. This last one I'm actually going to change up because I want you to get some more practice, and we're just going to leave this as x, I think. This might come back to bite me because I'm changing it on the fly, but it's fine. Okay, so if we just look at the g function now, and we have to plug in x to the g function twice, let's see what it would look like. So start with those inner parentheses, but everything you don't use, you copy down into the next step. So I'm going to copy that first g down, and now I'm going to plug x into the g of f function, which just ends up being 5x. Because when I plug it in, that's what I get. The purpose of the g of x function is to take every input and multiply it by 5. So if my input is only x, it's just going to be 5x. Okay? Now I'm going to do that again with my new input, which is 5x. So now I'm going to go to the g function. I don't copy the g because I'm actually going to plug it in. There's a 5 in front, and my new input is 5x. So then I get 25x. Okay? So that's that part of the lesson.